মানে বেলেগ সিস্টেম আমরা করেছিল না বেলেগ এটা কম্পিউটার ইউজ করছি কিন্তু মানে ভয়েস টো ইমান ভালকে নাহে
ঠিক আছে স্যার
Pero vamos a ver cómo
এতিয়া হৈছে চাগে এতিয়া হৈছে
এতিয়া আচ্ছা
সেই চেট বক্সত এইটো দি দিয়া
ঠিক আছে মই চেটত কুৱেশ্যন কেইটা দি দি আছো
কোৱেশ্যন কেইটা সেই আৰু লিংকটো ক'ত ইউটিউবৰ লিংকটো
এই টিমৰ লিংক য'ত পাইছে তাতে পাব সেইটো মেলতে আছে টিমৰ লিংক ইউটিউব লিংক
মেইল দিছা
ৰেখাবাৰ পৰা যাব লাগে নহ'লে মই আকৌ এবাৰ মেলত দি দিওঁ লিংকটো নাইবা টিমত
তোমাৰ ৰেখাৰ পৰা আহিব ন
এইটো লিংক য'ত পাইছে তাতে আছে তলত
ৰেখা হাজৰিকা এইটোতো মানে মই সেই হেৰি কৰি থৈছিলো এইটো 4:30
25
3 to 4 এইটো আছে observation কোন 15 উঠাই গৈছে
কি হৈছে
এইটো তোমাৰ সেই সাস্টেইনেবল পাৱাৰ জেনাৰেশ্যনৰ কথাই কৈছে এইটোত তুমিতো পঠাই দিয়া নাই মোৰতো নাই নেকি এইটো প্ৰগ্ৰামে আছে এইটো সাস্টেইনেবল পাৱাৰটো আছে চেট বক্সটো পঠাই দিয়া পঠাইছে
चालू थे तो 2 पेज था उसमें एक का हम लोगों का आंसर गलत हुआ था तो जस्ट करेक्ट उसने बोला कि हम लोगों का करेक्ट है तो लेक्चर्स में ही एक सॉल्व क्वेश्चन नंबर 2 था तो जो दूसरा था वो इन जनरल था कि ब्रिटिश हम लोग कोडिंग यूज क्यों करते हैं कि इंडियन स्टैंडर्ड से वो पुराना वाला है ना तो ज्यादातर लोग वही यूज करेंगे वाइड एक्सेप्टेंस के लिए ऐसा अगर वो क्वेश्चन
ऐसा क्वेश्चन तुमको पहले देना चाहिए ना अभी मैं रिप्लाई दे देता हूँ वहाँ पे
मैंने रिप्लाई दिया है उसमें
हम टेंशन नहीं करेंगे Sunita, online আহিব পাৰি নেকি? এইটো মানে বেলেগ নাই নহয়, তোমাৰ এইটো হেৰিটো আছে আৰু বাকীটো এক্সেলৰটো নাই, এতিয়া ইয়াতে যি আহে তাতে মই ৰিপ্লাই দি দিম আৰু। এইটো কোনে দিছিলে? এইখিনি তুমি দিছিলা নেকি? assignment related questions are enough to prepare এইকেইটা যে? Okay, okay. So let me share my screen. Dear students, welcome to the second live session of the course Solar Energy Engineering and Technology. So in this live session, we'll be discussing from module 6 to module 10. And in the discussion forum, most of the queries has been updated. So I will just outline the content what we have covered in those modules. So as I said, in module 6, we have grid connected PV systems, and module 7, fundamentals of flat plate collectors, followed by collector flat plates, liquid flat plate collectors in module 8. And then solar air heater was discussed in module 9, and in module 10, solar concentrating collectors were elaborated. So in lecture 1 of module 6, we have primarily covered the layout of grid connected PV systems, different components of a grid connected PV system, then how these different equipments can be selected for a particular purpose, then role of different components for maximization of PV systems has already been elaborated. In lecture 2 of module 6, the design of grid connected PV systems has been discussed. How this voltage, current, and power ratings of modules and inverters are connected, and the 3 more important criteria which ensures a proper matching of the systems in terms of performance and safety. And also clear-cut design steps has been elaborated. Sizing of the inverter based on the size of the arrays have been included and discussed extensively. And finally, we have design design demonstration with an example has been provided. In lecture 3 of module 6, a systematic performance analysis of a grid connected PV systems has been elaborated, and also we have considered the discussions on a practical problems, and we have shown how these parameters which characterizes a grid connected PV systems has been elaborated. So that includes like energy yield, specific yield, performance ratio, capacity utilization factor, the average system performance of a grid connected PV system. So as you can see here, as you can figure it out, like what are the components are required to complete a grid connected PV systems. We need a set of PV modules, and we need DC cables to connect the DC energy what is generated here, and then it goes to inverter, and we'll have AC load because inverter converts the DC power to AC power or alternating current. And also we can connect to a meter, and this is nothing but net meter. That means the amount of energy what you are producing that is accounted by this meter, and also the amount of energy when there is no solar energy generation, how much energy we are getting from the grid. And this is managed by this net metering system. And in lecture 1 of module 7, we have discussed about the fundamentals of solar collectors, which includes classifications of collector system. Then what are the flat plate collector components? For example, like liquid water, sometimes we can use glycol as well. Suppose if the temperature of the ambient air goes below 0 degrees Celsius, then water will be like converted to ice. But we need a fluid which will not freeze. So ethylene glycol is one of the fluids which is mostly used in those applications. And also we need to know the kind of absorber plate to be used for the purpose. Then tube material. Then what could be the thickness, its dimension. Then the header pipes. What are the insulations? What kind of material to be used for collector boxes? These are the fundamental things we need to know. And then performance analysis of flat plate collector is very, very important. On the top of it, its instantaneous efficiency and stagnation temperature is very, very important. So once we know stagnation temperature, then we can find out what could be the appropriate material for the particular design. Because this stagnation temperature indicates the maximum temperature which can sustain by the material. And also we must have some ideas about transmissivity calculations and the significance of transmissivity absorptivity product. In lecture 2 of module 7, we have included the different modes of heat transfers and the non-dimensional numbers which are required for estimation of heat transfers in different situations. Mostly this arises in case of flat plate collectors, that means thermal collectors. In lecture 1 of module 8, we have extensively discussed about different losses which is taking place in a collector system and how these losses can be minimized. So while discussing, we have included independent discussion on loss coefficients. It may be top loss, bottom loss, side loss, and if we include all, it becomes overall loss coefficient. And also we have made sufficient discussion on demonstration of loss calculation associated with FPC by using iterative technique and use of correlations. So as you can see here, so this is an absorber plate. Normally below the absorber plate will have the tubes through which heat transfer fluid flows. It may be air or water. If it is a solar air heater, then we use air, or if we use water, then water also flows through. But normally we do not use tubes for solar air heaters. It's a channel, and air actually circulates, and then hot air can be extracted. So if we consider this absorber plate and try to write down the energy balance on the absorber plate, so our equation will look something like this. QU stands for useful heat gain, and APS is nothing but the amount of energy which is absorbed in the absorber plate, and QL is the losses. And this QL is nothing but sum of the losses taking place from the top, sides, and the bottom. That's how we can represent this QL in terms of this UL. UL is nothing but overall loss coefficient multiplied by AP. AP stands for area of the absorber plate, and TPM minus TA is nothing but the temperature difference between the plate and the ambient condition. Okay, and this QL is nothing but sum of all the losses, as I said before. It's top losses, side losses, and bottom losses. And this S is very complex term. And in order to find out this S, we need to find out this tau alpha average. So we need to take help of Snell's law and Bogar's law. And from there we can find out the values of transmissivity and absorptivity. We can anyway find out. And once you know this, and of course, we also need to know what is the beam radiation, what is the diffuse radiation, and then this is the coefficients. So once we are confident about those values, then we can find out S. And once you know S, then we can find out APS. That means amount of energy which is received in the observer plate. And this top loss, bottom loss, and side loss can be expressed in terms of bottom loss coefficient, side loss coefficient, and the top loss coefficient. So once we express this in terms of those coefficients, so we can actually transform this equation to this kind of equations, which is nothing but this overall loss coefficient is sum of top loss coefficient, bottom loss coefficient, and side loss coefficient. Okay, because this TPM minus TA is common for everywhere. So if we divide the expression for by TPM minus TA, then our equation will look like something like this. So overall loss coefficient is a measure of all the losses. That's what where we have arrived at now. And each value should be in the range of about 2 to 10 watt-meter square Kelvin. That means if your value of loss coefficient is more than 10, that means you are not doing a good design. And then in lecture 2 of module 8, we have extensively discussed about energy balance of an observer plate, thermal resistance network, temperature profile of a flat plate collector, then definition of collector efficiency factor, collector heat removal factor, instantaneous efficiency, and then series parallel connection of collector systems. So these are the equations we use. And one important equation, what we would like to mention is Hotel-Wheeler-Bliss equation. So as you can see, this QU here is a function of TFI minus TA. That means earlier expression, what we have expressed, like QE is equal to AP multiplied by S minus UL AP multiplied by TPM minus TA. So to know TPM, it's a really difficult job. But fluid inlet temperature is very easy to know because this is the temperature at which fluid is introduced into the system. So it is very easy to find out this TFI, and then we can do this calculation very easily. So here there are two different terms which is introduced in this expression, FDES and FR. What is FDES? FDES is nothing but collector efficiency factor, which is defined as the ratio of the actual useful heat collection rate to the useful heat collection rate, which would occur if the collector observer plate are at the temperature of TF, that is fluid temperature, mean fluid temperature, and its temperature varies from, and this temperature, this value of this varies from 0.8 to 0.95. And we have one more term called FR, which is nothing but collector heat recovery factor, and this is defined as the ratio of the actual useful heat collection rate to the useful heat collection rate, which would occur if the collector observer plate are at the temperature of fluid inlet temperature. And its value varies from 0 to 1. If we can make it 1, then we'll get a very good useful heat gain. So in lecture 3 of module 8, various parameters which influences the performance of flat plate collectors were elaborated. And some of the important parameters which we have discussed in this lecture is selective surfaces, number of covers, spacing, collector tilt, dust on the top cover, then evacuated tube collector system. Also, in the last module of last lecture of module 8, we have discussed about testing of liquid flat plate collector and its application. So testing is done this way. If we buy a new flat plate collector, or if you have to test the flat plate collector, we place in the frame and then we test the things at different conditions. By keeping fluid inlet temperature and mass flow rate fixed, we monitor data parameters and then we feed the performance. And as far as application is concerned, this flat plate collector can be applied in many applications like indoor swimming pools, water heating, milk pasteurization, power generation, drying, solar water heaters for biogas, and slurry drying. In lecture 1 of module 9, solar air heater was discussed. In this lecture, fundamentals of solar air heater, its performance analysis, and what are different types. These were elaborated. In second lecture of this module, primarily we have discussed about the heating testing of solar air heaters and how this can be applied in different applications. Also, we have shown some kind of drying calculations for drying of grapes, and also we have explored the possibility of using solar air heater for power generation. In first lecture of module 10, concentrating collectors were elaborated, mostly fundamentals of concentrating collector, its classifications, what are the basis of classification. It may be reflecting type utilizing mirror, refracting type utilizing Fresnel lenses, imaging, then concentration ratios, tracking, and also how this energy balance can be expressed, and then finally analysis of parabolic trough collector and heat transfer. So these were discussed. In second lecture of module 10, considering collector technologies and its working principle were discussed, and also its comparison of different collector system has been elaborated. That means power towers and troughs are best suited for large grid connected power projects, which is in the range of 30 to 200 megawatt. And these engine systems are modular and can be used in single dish applications for grouped in dish farms or create larger multi-megawatt projects. And parabolic trough plants are the most mature and solar power technology which is available today. And its analysis were also discussed. So these were the components we have discussed from the end of what is called first life to this second life session. And there were some queries I would like to see here. Like there were some something like is assignment related questions are enough to prepare, or any out of syllabus questions should be given in the final exam to score pass mark. Little tough to understand problems. Please give brief explanations for pass marks, sir. It is mandatory to pass this subject, so I like it. So yes, of course, no, most of the questions of what we have given in the assignments, you please carefully study those things. And since all the queries has been given, all the solutions has been given, then I think it is not tough to score um, many marks, and no questions will be asked from outside syllabus. The content what we have discussed in the lectures and in the discussion forum and also in the assignments, from there only question will be asked. You don't have to worry. So prepare well by considering all these aspects. Then I think you will not face any difficulty. So one more questions one student has asked: Can thorough modeling and performance analysis of solar collector be possible in Fluent software or need some additional tools? Of course you can do, and there are some other software as well, like Pollution. We normally use for performance evaluation, and I think this tool is also good for analyzing the performance. You may go ahead. And one more question was there: what would be the proper style, paper style, and how much weightage will be given to examples? So see, there are things are clear. So everything is written in the portal, and you just follow all the instruction given there. But in my opinion, you concentrate more on assignments and the class notes. So these two components, if you could concentrate, then I think it's fine. And of course, you need to submit the assignment regularly. This is also important. So if you prepare nicely all the assignments and the lecture notes, I think you can score a good marks. If there are any questions, you can ask me. Number of questions in exam, I can't say, but total marks will be about 100 marks. So multiple questions. So these are MCQ questions, and then options will be there. You need to do the things what you have studied in the when you have solved the problems uh, in the assignment, then that kind of problem will be asked. Different categories of questions will be there. So I think you don't have to worry much if you have done the assignment seriously. If you have any questions, please ask. Any question? So there's a questions on the increase of grid connected PV system. What are the applicable tariff charges applicable for individuals who sells his? So this actually depends on the discom. So if you are in Assam, then things will be different, and if you are in Delhi, your tariff will be different. So I think when we sell from our side, we get less, and we pay more when we take from them. It's difficult to send the whole question paper because we don't deal with that. NPTEL MOOC section, they takes everything, so we don't have anything actually. So they take care of all the question publishing. They do. We don't have any control about it. I'm not sure what are you talking about. Where we can get notes. Everything is there in the videos, and then I think you have all those PDFs also. Is there? You have to spend some time in watching the videos. What you should do, you see the videos and follow the assignments and exercise for some time, and this much of preparation is enough to score good marks. Um, so you said solar flux below my solution matches it, but after slightly large difference in space, place the request and we'll solve the entire problem once again for you. So if your question is something like how this the heat removal factor influences the final result, then no, you can really see these parameters are okay. So if you change those parameters significantly, that means my anticipated value is say 0.8. If you consider say 0.4, of course your things will be different. Any other participants who want to speak something? Participants who want to speak something? I think in the portal you can get those transcripts. And in my opinion, you should concentrate more on assignments. Numerical seems to be very lengthy, time consuming, and so I think you don't have to worry about this no length of the problems. So if you understood, the content, then I think it is very easy to solve the problems. So the kind of problems to be asked in the exam is not to disturb you. I know it's not a very lengthy problem. So small problems will be asked and you need to answer. And if it is somewhat longer, then you will get more marks. So that's how it has been designed. So if there is no such questions, then I can lead the session. So thank you very much for your attention and coming to this live session. Thank you. And I wish you all the best for the exam.